tech enthusiasts. Have you ever wondered how machines learn to make decisions? Imagine a robot learning to walk or a computer mastering a video game. That's where reinforcement learning comes in. Today, we're diving into this fascinating world of AI. We'll explore how agents learn by interacting with their environment. And don't worry, we'll also touch on some important ethical considerations. So let's get started on this exciting journey into reinforcement learning. Reinforcement learning is a type of machine learning. It's all about learning through trial and error. Think of it like training a dog. You reward good behavior and discourage bad behavior. In reinforcement learning, our dog is called an agent. The agent learns by interacting with its environment. It tries different actions and sees what happens. When it does something good, it gets a reward. When it does something bad, it might get a penalty. Over time, the agent learns which actions lead to the best outcomes. Let's break down the key components of reinforcement learning. First, we have the agent. This is the learner or decision maker. Next, we have the environment. This is everything the agent interacts with. Then we have states. These are situations the agent can be in. We also have actions. These are things the agent can do. And finally, we have rewards. These tell the agent how well it's doing. Now let's see how this works in practice. Imagine we're teaching a robot to play chess. The robot is our agent. The chessboard and pieces are the environment. Each arrangement of pieces on the board is a state. Moving a piece is an action. Winning the game gives a big positive reward. Losing gives a negative reward. Making good moves might give small positive rewards. The robot starts by making random moves. Sometimes it wins, sometimes it loses. It remembers which moves led to wins. Over many games, it learns which moves are best in each situation. Eventually, it becomes a skilled chess player. This same process can be applied to many different problems. Self-driving cars use reinforcement learning. They learn to navigate roads safely. Stock trading algorithms use it to make investment decisions. Even recommendation systems on streaming platforms use reinforcement learning. They learn which shows you're likely to enjoy. Now let's talk about how agents actually learn. They use something called a policy. A policy is a strategy for choosing actions. At first, the policy might be random. As the agent learns, it updates its policy. It tries to maximize its total reward over time. There are different ways to update the policy. One method is Q-learning. Q-learning estimates the value of each action in each state. Another method is policy gradient. This directly optimizes the policy without estimating action values. There's also Actor-Critic methods. These combine ideas from both Q-learning and policy gradient. Reinforcement learning has some unique challenges. One is the exploration-exploitation trade-off. Should the agent try new things, which is explore? Or should it stick with what it knows works, which is exploit? Another challenge is delayed rewards. Sometimes the effects of an action aren't immediately clear. These challenges make reinforcement learning an exciting field of research. Now let's consider some real-world applications. Reinforcement learning is used in robotics. It helps robots learn complex tasks like grasping objects. It's used in game AI. This is how computers learn to play games at superhuman levels. It's also used in resource management, for example, optimizing energy use in data centers. But with great power comes great responsibility. We need to consider the ethical implications of reinforcement learning. One concern is bias in the training data. If the environment doesn't represent the real world fairly, the agent might learn unfair behaviors. Another concern is transparency. It can be hard to understand why a reinforcement learning agent makes certain decisions. This is especially important in critical applications like healthcare. We also need to think about safety. A reinforcement learning agent might find unexpected ways to maximize its reward. These could be harmful in the real world. For example, a cleaning robot might break objects to avoid having to clean them. That's why it's crucial to design reward functions carefully. There's also the question of AI alignment. How do we ensure AI systems have goals aligned with human values? This is a complex philosophical and technical challenge. It's an active area of research in AI ethics. As we develop more powerful reinforcement learning systems, these ethical considerations become increasingly important. We need to strive for fairness, transparency, and safety in our AI systems. This requires collaboration between technologists, ethicists, and policymakers. And there you have it, folks. That's our journey through the world of reinforcement learning. We've seen how agents learn by interacting with their environment. We've explored applications from chess to self-driving cars, and we've considered some important ethical questions. I hope this video has sparked your curiosity about reinforcement learning and AI ethics. If you found this interesting, please give the video a like, share it with friends who might be curious about AI, and leave a comment with your thoughts or questions about reinforcement learning. Thanks for watching, and until next time, keep learning and stay curious.
Thank you for watching. Join us for engaging topics, clear and concise explainers, and tutorials that will help you navigate the complexities of AI responsibly. We also believe in the power of community. Your questions, comments, and feedback are what make this journey exciting. So, don't hesitate to join the conversation and share your thoughts with us. Are you ready to embark on this journey towards a more ethical and responsible AI future? Hit that subscribe button and turn on notifications so you never miss an update. Together, let's shape the future of AI responsibly.